And then, what is the overall charge? It's a 2 negative. 2 negative for the overall charge. Alright, now on the bottom, we're back over to P12 about sodium. We're back over to P12 about sodium. Yes?
Do you mind if I close the door?
Not at all. So on the bottom of P12, and we're talking about sodium, we're supposed to write things that are similar about an atom of sodium and an ion of sodium, and then things that are different about the atom of sodium and the ion of sodium. So, for sodium, on the bottom, on that first line, I'm going to write the word similar. And I'm going to put an equal sign. So in that first line for question number 3, I'm going to put a similar and I'm going to write an equal sign. What's something that we found is similar as you look at your 2 drawings for sodium atom versus a sodium ion? Same number of protons. So what I would do, something that's similar, just shorthand. Number of protons. Number of protons did not change between the 2. Anything else that was similar? Between the sodium ion and the sodium atom.
That there were two atoms in the first energy level.
2 electrons in the first energy level. So here's how I'm going to write that. 2 E negative in first E capital L. 2 electrons in first energy level. Absolutely. I think that might be all that I can come up with. Or that you can come up with. Similar. And then on the next line we can write different. What is different about them? Energy levels. So this guy, ion, has 2 energy levels, but the atom had 3. So different, I would just put capital E, capital L, and a number sign in front of it. So the number of energy levels, absolutely. Number of energy levels is different. What would be the very most important thing that you could tell somebody that's different about the sodium atom versus the sodium ion?
There's more electrons in the last.
Not only more valence electrons, but specifically 8, the magic number of 8. Instead of having 1 on the outside, it's got 8. So I would put 8 valence electrons. And then in parentheses put ion. I think that's the easiest way to write that. 8 valence electrons. That's the most important thing. That's why that atom did what it did. It lost that electron so that it could have 8 valence electrons. It changed the number of energy levels, but that's not why it did that. It just so happened it changed the number of energy levels. Alright? So if we come over here to the oxide, so we flip over to P13. We flip over to P13, we're going to do the same thing. Similar. And I think we could probably come up with some more differences as well. The total number of electrons, things like that. Once again, same number of protons. So similar number of protons. 2 energy levels. Oh yeah, something that's similar about here is the number of energy levels. The number of energy levels didn't change for oxygen. So similar to, and then I'll put E period L's for energy levels, 2 energy levels. It's the most important thing you could tell me that's different about the oxide ion versus the oxygen atom.
It gained.
It gained 2 electrons. Why?
Because that's what it does. Because the magic number is 8.
We wanted to have 8 on the outside, and then originally or started out as only having 6. So something that's different is the 8 valence electrons for the ion. And that's the most important. There's a lot of other differences, but those are the very, very biggest difference. 8 valence electrons. Both of them wanted 8 valence electrons. One gained electrons to do it, one lost electrons to do it. We're going to find out the ones that are losing electrons to do it. We will call them a name. We will call them a metal atom. The ones that are gaining electrons to get that 8 valence electron, we will call them non-metals. What we're going to be talking about today is explaining that the periodic table is organized so that elements in the same column have similar properties, which means they behave the same. That's how the periodic table is organized or arranged. Now, what I'd like to do is take a look at everybody in column 1A. What I want you to notice about all the elements in column 1A. Hydrogen is the first element in column 1A. Hydrogen is very simple. It's got one little proton, it's got one energy level, and on the outside it has one electron. Right below hydrogen on the periodic table is lithium. Lithium has three protons, and 2 energy levels. But what I want you to notice about lithium, right below hydrogen, is it also has one outer electron. We'll go one more. Next guy, 11 protons in the nucleus. 11 protons in the nucleus. 3 energy levels. 3 energy levels. But what you will notice about this atom is it also has
One electron.
one electron on the outside. One valence electron or one bonding electron. So, as each of these atoms are flying around wanting to react, wanting to bond, wanting to connect with other atoms, as another atom sees it, all it sees, all it notices is on the outside it has one electron. On the outside it has one electron. On the outside it has one electron. So as from another atom's standpoint, all of these atoms look very, very similar. They almost look exactly the same. Obviously their sizes are different, but from the outside perspective they all look similar or the same. Because of that, all of these atoms have similar properties. They behave the same. As we found out yesterday, we found out that sodium is a metal that wanted to lose electrons, and we found out that sodium wanted to lose one electron. Well, lithium also wants to lose one electron. So they act or behave similarly to each other because they all have one electron. The periodic table was intentionally set up that way so that the elements in the same column are set up so that they have the same number of valence electrons because that determines that they will have similar properties. Yes, sir?
Who made the periodic table elements?
Well, Mendeleev was the first guy putting these elements together. And what he didn't know about protons or valence electrons or any of that. But what he knew was lithium looked like and acted like sodium. They behaved similarly. They had the same color, they had the same shininess to them, they reacted with the same things. So he said, all right, when I set up this periodic table, I'm going to put lithium and sodium right on top of each other because they behave the same. And so what they did is they originally set up the periodic table so that these columns, all the elements that were a greenish gas and reacted with water, they all went in here. All of them that were a shiny silver and they all went in this column. And so even before they knew about the valence electrons, they set them up according to their properties, and then later discovered, oh, their properties are based off their atomic structure and how many electrons specifically there are on the outside of that atom. So they did the properties first, found out later it was based off those valence electrons on how they react. Good question. Good question. So today what we're going to do on our big periodic table is we're going to use our pencils to color in columns, also known as groups, also known as families. Because whether you like it or not, there are certain characteristics about your family that you carry out once you leave from that family. That you act or behave the same or similar in certain situations. Okay?